Okay. Let's do one more example of recursive sequence. We'll move on to the next part of 12.1. Example 4. I'm going to give you a sequence here. -2, or -7, -2, 3, 8, 13.
And you want us to put it in that previous kind of formula?
I'm going to actually ask you to do two things. Write a recursive formula. Part B is to write an explicit formula. This is a recursive formula, something like this. You start with the first term, and then you tell a way to find the next term in the sequence. That's a recursive formula. An explicit formula would be one like this. A sub n equals 2n plus 1. The explicit formula can tell you any term of the sequence. The recursive formula can only tell you the next term of the sequence based off the term in front. So there are two different ways of giving the same sequence. So let's start with the first one, recursive. How do we start with the recursive formula? We have to know the first term. How do you describe the first term? Using symbols. A sub 1, since it's the first term, equals -7. So there's the first term. Now, a sub n plus 1 represents the next term. We know that the first term is -7. A sub n plus 1 will be the next term. How do we get that next term?
A sub n plus 5.
A sub n, which is the current term, plus 5. A sub n plus 5. That's the pattern, right? You add 5 to get to each term of the sequence. So this would be considered a recursive formula. You know where to start, and you know how to get to the next term. An explicit formula is more like an equation that would describe this if this were a function. What I mean by that is if we had an input-output table with n and a sub n. When n equals 1, that's the first term of the sequence. Then we have -7. If n equals 2, which is the second term of the sequence, we have -2, and so on and so on. So we'd have to come up with a function that describes that input-output relationship. Okay? The key here is it's a common difference between terms. It's the same. We're adding the same number every time. Okay? It's a constant change, right? What other type of function has a constant change? Linear function. So we got to come up with an equation that's linear that describes this relationship. So it's a sub n
I just put n plus 5.
n plus, let me do a couple of things here. N plus 5, okay? If n equals 1, that would give us a 6, but it should be -7, right? Now I'm hearing a lot of people say 5n plus something or minus something. Okay, why the 5n specifically? That's the slope. That's the constant change, right? In a linear function, the slope represents the change. Okay, but plus what?
-12.
Let's test this. 5n minus 12. If n equals 1, what are we supposed to get? -7. Does that work in this formula? If n equals 1, we get -7. Yeah. If n equals 2, we're supposed to get a -2. Here, if n equals 2, 5 times 2 is 10. 10 minus 12 is -2. Would it work? Now, it works for the first two terms. It worked for everyone, though. We got to test that. Would it work for the, what is this, the fifth term here? Would this also work for the fifth term? 5 times 5 is 25. 25 minus 12 is 13. So this is called the explicit formula. This formula can give you any term in the sequence at any point, not just a term based on the one in front of it. That's the two differences there in types of formulas. There's a recursive formula and an explicit formula. Okay, the next objective. Where are you? Where are you? Partial sums. All right. Why can't we add up an entire sequence? Why does it have to be only a partial sum? They go on forever, don't they? A sequence is an infinite list of numbers. Is it possible to add up an infinite list of numbers?
No.
Actually, it is. We're going to find that out in the next section. But not with these types of sequences that we're doing right now. So we're only going to add up a partial sum, part of the sequence. So the notation here, S with a subscript of 1, that just means you add up the first term. If you only add up the first term, you're going to get the first term. Okay? And S with a subscript of 2 means you add up a sub 1 plus a sub 2. And S with a subscript of 3, you get the pattern, right? And so on and so on. So for example 5, I want you to find S sub 4 of the sequence given by this formula, a sub n equals 1 over 2 to the n. Now, if you had to describe that formula, would that be a recursive formula or an explicit formula? Why explicit? Okay, it doesn't have any n minus 1 or n plus 1. We could use, if I asked you guys for the 10th term of the sequence, you plug what in? A 10, right? And that would give you the 10th term. Do you have to know what any term before that is? No. Okay. This is an explicit formula because you can find any term at any point you want. It doesn't have to refer back to previous terms. Yeah?
2 square or 2 to the square root of n?
2 to the power of n. 1 over 2 to the power of n. So, you guys, in order to find S sub 4, what do we have to know?
N1, N2, N3, N4.
We have to know the first 4 terms. Yeah. Just, it's 1 over 2 to the n. So in order to find S sub 4, we have to know the first terms to add them up, the first 4 terms in particular. So what's the first term?
1.
How do we know that? You guys are right. What are we plugging in?
1.
The number 1 for n, because for the first term, n equals 1. So the first term is 1/2. Now we have to add that to the second term. For the second term, n equals 2. So that's going to be 1/4. Now we have to add the third term, which is 1/8. And then finally we add the 16th. 1/2 plus 1/4 plus 1/16. Or plus 1/8 plus 1/16. This has to be added by hand. So they have to be in terms of 16ths to get a common denominator. 8/16 plus 4/16 plus 2/16 plus 1/16. So yeah, 8 and 4 is 12, plus another 2 is 14, plus 1 is 15, so this is 15/16. If we add the first 4 terms,
And then what does this do to our knowledge?
it's practice for what we're doing next, really. This notation is very, very limited, because using this notation of S sub 4 or S sub 2, that only allows you to add the first 4 terms, or the first 2 terms. What if I wanted you to skip the first 4 terms and add the 4 terms after that? Or what if I wanted you to skip 50 terms and add the next 50 terms after the first 50? You know what I mean? This notation doesn't allow you to do that. Using this notation, you're only limited to add the first however many terms of the sequence. So this next notation is still a partial sum, because you're only adding part of the sequence, but it's not the first couple of terms in particular. This is what's called sigma notation. It's still partial sums, but using sigma notation, you can start at any point in the sequence and add as many terms as you need to. Now, sigma is a letter in the Greek alphabet. That's why it's called sigma notation. You've probably seen this before in math books and never really knew what it meant. Well, that's a terrible name. Looks a lot like this. Looks like an E, but in the Greek alphabet, it's a capital letter S. It is pointed. I just draw it like this because it's easier. This stands for partial sum. When you see this symbol, that means you're going to be adding up terms of a sequence. Okay? This is the letter sigma. Okay, so put this at the bottom. Put this on the top. And this is not in general. This is just a specific example. This is how you would see sigma notation written. Let's label these so you know what we're talking about. N equals 1. This is the beginning value of n. The number on top is the ending value of n. The expression to the right side of sigma is the explicit formula. Of the sequence. So you have to know and you have to learn how to interpret this. If you just see that symbol, you have to know, first of all, you have to know that sigma means what? When you see sigma, what does that mean? A partial sum. Okay, so then the next thing you got to know is, well, how many terms am I adding up? So looking at this, if we're starting when n equals 1 and we end when n equals 10, okay, that's how many terms we're going to add up. How is this any different than what we were just doing? Why is this better? This is a little bit better way of doing partial sums.
Because you can change the beginning value.
Yeah, we don't have to start at n equals 1. What if I started at n equals 8? And then ended when n equals 10. How many terms would that be, by the way? If we start with n equals 8, that'd be 3 terms, right? Because we have n equals 8, n equals 9, and n equals 10. That'd be the 3 terms. Okay? So you can change these things around. That's why the sigma notation is a little bit nicer than partial sum notation, because you can start wherever you want and end wherever you want. So let's do an example. Example 6. Evaluate So we're supposed to find a partial sum. But in order to add up terms of a sequence, we have to know what those terms of the sequence are. Now, how many terms are we adding up? Are we adding 5 terms? Okay. So what are those 5 terms? So we're adding the number 1 plus 2 plus 3 plus 4. How do we get the terms of the sequence that we're supposed to be adding? We have the formula, 2n minus 4. Which n values do we use? It tells us what n values to use. We start when n equals 1 and we stop when n equals 5. So if n equals 1, that's this first term right here. What's the number of the sequence? -2. If n equals 2, we get a 0. If n equals 3, we're going to get a 2. When n equals 4, we get a 4. And when n equals 5, we get a 6. Those are the first 5 terms of this sequence. Okay, so the partial sum is what? 10. Let's try another one. Part B. It doesn't always have to be n. Whatever variable is used at the bottom of sigma has to be the same variable used to the right side. But as long as they match, it doesn't matter. Now, how many terms are we adding here? We're adding 4 terms. We start when I equals 3. So whatever term that is, we have an I equals 4, we have an I equals 5, and we have an I equals 6. So whatever those terms turn out to be, we have to add all 4 of those. So when I equals 3, what are we getting? 10. When I equals 4, 13, 16, and 19. Okay, we add up those 4 terms. Is it 58? I'm trusting you guys. Is it 58?
Yeah.
Okay. Let's go the other way now. I'm going to give you a partial sum in this notation here, where it's already been expanded out. You need to go backwards and write it using sigma notation. So here's example 7. Express using sigma notation. So there's a partial sum. And there's no dot, 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 because we're only adding this specific terms of whatever sequence this is.
we know what number
Exactly. I was just hoping somebody would recognize that. How do we know that -1 is the first term? We don't. So there actually are an infinite number of ways you could answer this. But most students would assume that -1 is the first term. And if you do, that's fine. Your answer that you give would be right. But you don't have to assume that -1 is the first term. But for the sake of ease right now, let's assume -1 is the first term. Let's see what we get. And I'll show you that it doesn't have to be the first term. What's really the most important thing that we need to know right now? The rate of change. Okay, we need to recognize some kind of a pattern, and yeah, we have to recognize the pattern so we can write a formula for it. If we don't have the formula, then all we would have is, okay, we could have n equals 1, n equals 6, but we don't know what the explicit formula is. So, is there a constant rate of change? Is it? We're going up by the same number every time. We're going up by 4. That means this is going to be a linear relationship. A constant rate of change is like the slope. If you were to graph that, what would the slope be? 4. So we need to find the explicit formula. A sub n, we know is going to be 4n plus something or minus something. Why 4n? That's the rate of change. That's the constant rate of change of 4n. 4n what? Minus 5? 4n minus 5. Let's test that. Let's test 4n minus 5. So if n equals 1, what should we get? A -1. And do we? If n equals 1 here, 4 times 1 minus 5, -1. If n equals 2, we're supposed to get a 3. 4 times 2 is 8. 8 minus 5 is 3. So this appears to be okay. So the explicit formula is 4n minus 5. And assuming that this is the first term, we could say that n equals 1 all the way up to what? 6. Now, here's what I mean by this is not the only correct answer. Consider this. Hold on. If we start at 2 and go to 7, is that the same number of terms? It's still 6 terms. The problem is we'd have to have a different formula. 4n minus 9. Hold on, you guys. You'll be fine. Consider this formula. 4n minus 9. If you plug in a 2 for this thing, and then subtracted 9, wouldn't you still get a -1? And then a 3 and then a 7. So that answer is correct. Huh? No, just 1.